Now, as for the flow of water in waterfall, difference in altitude or potential energy is required. Similarly, for the current to flow, difference in voltage is required. And this voltage difference is provided by an electric cell. So, here we have an electric cell, and the electric cell acts as a voltage source and provides the necessary push that causes the electrons to flow through the wire. Now for this, we have to connect one end of a piece of wire with the negative terminal of the cell. That corresponds to the low voltage in case of conventional current. And one end of another piece of wire is attached to the positive terminal of the cell. That corresponds to high voltage. Between the free ends of these two wires, an electric bulb is connected. And what will happen next? Yes, electrons from the negative terminal of the cell will push against the randomly moving free electrons in the wire and reach the positive terminal of the cell through the electric bulb. Here you can see that the bulb glows. So this forms a closed circuit. Now students, you might be thinking, if we have something called closed circuit, then is there something called open circuit too? As the opposite of closed word is open. Well students, you're thinking right. And yes, there is a term called open circuit, which means that if a wire breaks somewhere in the circuit, or the wire is removed from the positive or negative terminal of the cell, or the switch is in off position, then this forms an open circuit, which thereby restricts the directional flow of the free electrons. Now let's draw it diagrammatically. So in this way, electrons move from negative terminal to the positive terminal of the cell through the electric bulb, while current moves from the positive terminal to the negative terminal of the cell. Now you might be thinking that why the direction of current is opposite to the direction of the flow of electrons, even when current is the flow of electric charge, which is nothing but the electrons. So my dear students, let me clear your doubt that in an electric circuit, direction of the conventional current is taken from positive to negative terminal of the cell. And why is it so? Well, it is so because in 1752, prior to the discovery of the electron, Ben Franklin chose a convention regarding the direction of current flow. He assumed that positive charge carriers flowed from positive to negative terminals. But it was actually the electrons that flow. An electron was discovered much later by J.J. Thomson in 1897. So, conventional direction of current is taken as from positive to negative terminal of the cell. And conventional current flow is the standard that most of the world follows, as scientific community made no effort to change it. So always remember, electric current flows from positive to negative terminal of cell, while electrons flow from negative to positive terminal of the cell. So with this, I end this module, and in our next module, we will discuss about the basic parts of an electric circuit.